Bismillahirrahmanirrahim. How are you, students? Today we will start lecture number 21, chapter number 3, Dynamics. Today topic is practical application of centripetal and centrifugal force. First application is banking of roads. When a car is moving along a curved road, a curved path, it is performing circular motion. For circular motion, it is not necessary that the car should complete a full circle. An arc of a circle is also treated as a circular path. We know that centripetal force is necessary for circular motion. If centripetal force is not present, the car cannot travel along a circular path and will and will instead travel along a tangential path. For example, if this car is moving in this circular path, and here there is no necessary centripetal force on this car, it will move in this path tangent to the path. Tangent is a line which touches the circle at a single point. Tangent line will move along a tangent line. Banking of road. This is road. This side is little higher as compared to this one. So when the outer edge is little higher as compared to the inner edge, it is called banking of road. What is banking of road? The process of raising the outer edge of a road over the inner edge through a certain angle is known as banking of road. Banking of road. Purpose of banking of road. Banking of road is done to provide the necessary centripetal force for circular motion. Second, to reduce wear and tear of tires due to friction, to avoid skidding, to avoid overturning of vehicle. These are the purposes of banking of road. Centrifugal force. This is basically a centrifuge. Washing machine dryer is a centrifuge. Work on the basic principle of practical application of centripetal and centrifugal force. Centrifugal force. Washing machine dryer. The lid of the cylinder container is closed after putting wet clothes in it. When it spins at high speed, the water from wet clothes is forced out through these holes due to the lack of centripetal force. These are the holes. Through which water are forced out. Cream separator work basically on the practical application of centripetal and centrifugal force. Heavier particle will move away from the axis of rotation, and lighter particle will move towards axis of rotation. On this principle, cream is separated from the denser from its other contents. Most modern plants use a separator to control the paste contents of various products. A separator is a high-speed spinner. It consists of a bowl which acts on the principle of centrifugal force. Now, numerical problems. First you will write data. A force of 20 Newton moves a body with an acceleration of 2 meter per second square. What is the mass? First you will write the data. Force is 20 Newton. Force is 20 Newton with an acceleration. Acceleration is 2 meter per second square. Find the mass of the body. So if is according to Newton's second law, if is equal to ma, mass is equal to F divided by A. So force is 20 Newton divided by 2 meter per second square. So mass is equal to 10 kilogram. The weight of a body is 147 Newton. What is the mass? Answer: weight of the body is 147 Newton. The value of G is 10. For simplicity we use its 10 meter per second square. What is the mass of the body? W is equal to mg. M is equal to W divided by G. W is equal to 147 Newton divided by 10 meter per second square is equal to 14.7 kilogram. How much force is needed to prevent a body of mass 10 kilogram from falling? Answer: the force needed will be equal to the weight of the body. Mass is 10 kilogram. W question mark G is equal to 10 meter per second square. So you will write W is equal to mg is equal to 10 kilogram 10 meter per second square is equal to 100 kilogram per meter square. Now find the acceleration produced by a force of 100 Newton in a mass of 50 kg. So write data. Mass is 50 kg. Force is 100 Newton. Find the acceleration per unit mass. Force per unit mass. Force is 100 Newton divided by 50 kg. Acceleration is equal to 2 meter per second square. A body has a weight of 20 Newton. Weight is 20 Newton. How much force is required to move a body vertically upward with an acceleration of 20 meter per second? 20 meter per second square. Force question mark. The force needed will be equal to a part of it is used to overcome the weight and the rest of the force is used to produce an acceleration of 1 meter per second square. So we will use this formula, but before going to use this formula we have to find out the mass of the body. Mass is equal to W divided by G. W is equal to 20 Newton and G is 10 meter per second square. So mass is equal to 2 kilogram. Mass is equal to 2 kilogram. Then using the formula, F is equal to W plus ma. W is equal to 20 Newton plus mass is 2, acceleration is 2 meter per second square. Total is equal to 24 Newton. Out of 24, 20 is used to overcome the gravitational force and the rest will produce the acceleration which is the required condition for the question. This is not included in your syllabus. This is also not included. How much time is required to change 22 Newton second? Del P divided by del T is the rate. It is del P data. Del P is 22 Newton second. Change in momentum. Force is 20 Newton. We have to find time. So according to the relation, F is equal to force momentum relation, del V divided by del T is equal to del P divided by F is equal to 22 divided by 20. So del T is equal to 1.1 second. 1.1 second. Now, how much is the force of friction between wooden block of mass 5 kg and horizontal marble floor? The coefficient of friction between the wood and marble is this. Coefficient of friction is 0.6. Mass is 5 kg. How much is the force of friction? F is equal to force of friction is equal to kinetic friction is equal to mu k into mg. 0.6 multiplied by 5 multiplied by 10, it will be 30 Newton. Now, how much centripetal force is needed? So centripetal force question mark is needed to make a body of mass 0.5 kg. Mass is 0.5 kg. To move in a circle of radius 0.5 centimeter. Divide by 100, we will get into meter with a speed of 3 meter per second. Now centripetal force is equal to mv square divided by r is equal to 0.5 3 divided by 0.5, it is equal to 9 Newton. Now revision. The first topic we studied in this chapter is dynamics. The study of motion, that branch of mechanics in which we study motion of objects and causes. The causes to produce. The second thing we studied is the inertia. We stated that property due to which it opposes any change in its state of rest or that of motion. Inertia is the second topic. The property of the body due to which it opposes change of state. Opposes change of state. The third topic we studied that is definition of force. anything which produces acceleration. Produces acceleration or tends to produce acceleration. Or tends to produce acceleration. The unit of force is Newton. Unit of force is Newton and can be defined as we know that F is equal to ma, 1 Newton, 1 kilogram, 1 meter per second square. The force is said to be 1 Newton if it acts on a body of mass 1 kilogram and produce an acceleration of 1 meter per second square. If force is said to be 1 Newton when it acts on a body of mass 1 kilogram and produce an acceleration of 1 meter per second square. Now the next topic we studied is Newton's first law. Newton's first law consists of two parts. Rest, a body in rest will remain in rest, and second part, a body in motion will continue its state of motion if no external force acts on the system. If external force acts on the system is zero. Momentum is the product of mass and velocity. The product of mass and velocity is called momentum, or that property which increase with increase in mass as well as velocity and decrease with decrease in mass as well as velocity is called momentum. Momentum is a vector quantity and its unit is kilogram meter per second, which kilogram meter per second can be expressed in Newton second as written as Newton second. Verification is already done. Now Newton second law. If a force acts on a body, acceleration is produced. The acceleration produced is directly proportional to the magnitude of force and inversely proportional to the mass of an object. Greater is the mass of an object, less will be the acceleration. Greater is the force, greater will be the acceleration. Newton's third law consists of states that for every action there is always an equal but opposite reaction. So action and reaction are always equal but opposite in direction. Negative sign is for direction. Negative sign is for direction. Now the next topic is force and momentum. Relation between force and momentum. If we have a body and initial velocity vi and mass m, it travels for a time t. Its velocity increases to v, mass will remain same. Then initial momentum here is equal to mvi, and here is the final momentum is equal to mvf. So change in momentum is equal to mpf final momentum minus initial momentum. So change in momentum is equal to mvf minus m vi. Now taking m common, del p is equal to m va minus vi. So writing here, del p divided by del t is equal to m vf minus vi divided by del t. Del p divided by del t is equal to m, and this vf and divide v minus vi divided by del t is equal to a. According to Newton's second law, this is equal to f is equal to del p divided by del t. So f is equal to del p divided by del t. Now law of conservation of momentum state that the momentum of an isolated system always remains constant. Momentum before collision is equal to momentum of the system after collision. Law of conservation of momentum state that law of conservation of momentum the momentum of an isolated system always remains constant. Momentum of an isolated system always remains constant, or momentum before collision. Momentum before collision is equal to momentum after collision. Initial momentum of momentum before collision is equal to momentum of the system after collision. Now then friction. Frictional force is the force which opposes the motion of one body on the surface of an other body. What is friction? The opposing force which acts in the opposite direction of the movement of the upper body is called friction. Friction force is mostly represented by small f, but in your book it is represented by capital F. Mu into Fn, normal force. F, kinetic friction. Mu k into R. Fn is equal to R, normal direction, and is equal to weight of the body. These three symbolic representation are used for the same force, which is weight of the body, or normal force, or normal reaction. Friction is of three types. Different types of friction exist: sliding friction, rolling friction, kinetic friction, limiting friction, static friction. If this body is in state of rest, then the force of friction between this body and this body is called static friction, and the maximum value of static friction is called limiting friction. And the force of friction, if this body slides on the surface of this body, then the force of friction is called sliding friction. And the force of friction between the rolling body and the earth surface is called rolling friction. This is how friction can be reduced. Friction can be reduced by lubricating different parts of machinery, by replacing sliding friction by rolling friction, by using ball bearings, by making the surfaces smooth, by making the shape of vehicles which type streamline. The best at least you must know three different ways with the help of which you can reduce friction. This chapter is finished. In next lecture we will do the short answers. Thank you students. Allah Hafiz. Wish you best of luck.